just want to make sure I understand all of the notation. So you're saying you're taking the power sets like n times, or like the like yeah. So and this is like the limit as n goes to infinity. Is that correct?
So what you do is for any natural number n, you include in this set the elements of the nth iteration of this process. So let me spell that out. I'm very pleased you asked this, by the way. OK, so what that guy is this. It's the union of n and the power set of n and the power set and the power set of n and so forth for every member of that sequence. So in other words, this piece contains every natural number and every set of natural numbers and every set of sets of natural numbers and every set of sets of natural numbers and so forth.
So isn't that equivalent to like the nth power set?
The nth power set, so it's going to differ in two different ways. The first way is that notice that although this guy is bigger than that guy, it's not true that every element in here is also in here, because that set consists entirely of sets of natural numbers and therefore contains no natural numbers, whereas this one consists entirely of natural numbers. So each time you progress in this hierarchy, you're actually introducing new stuff. What happens with a union is that it wastes nothing. So whenever you introduce new stuff, it includes the new stuff. So if we were just to take the nth level of this hierarchy, what would happen is that it wouldn't contain the stuff that came before, even though it would be bigger than everything that came before. Whereas here, nothing is wasted. But also, that set contains them all. Whereas if we took the nth set, then like that would be like it would be just like a limited, some finite stage of the procedure, where to get here you need all omega many stages. Excellent. Yes?
So it might be helpful to think about that in terms of the numbers of brackets around things, right? So like on that side, you'll have things without brackets, and then things with one set of brackets, and then two. And then here you'll have, for any natural number, you have all the things with that many brackets starting it.
Beautiful, beautiful. That's it. That's exactly right. That's exactly right. And in fact, that allows me to ask a question that's going to seem tricky at first, but in fact, that's important to really understand what's going on. So Rose is totally right. So here we have only natural numbers and no sets. So using Rose's notation, no brackets. Here we have sets of natural numbers. So it's going to be things like, OK, so the first member is that guy. The second member is going to contain the empty set, and the set containing only 0, and the set containing only 1, and then the set that contains 0 and 1, and the one that contains 0 and 2, and so forth. So as Rose pointed out, every element in here has one set of brackets. And then the next one is going to contain sets of these guys, so two sets of brackets. So here's a question for people. Does that mean that in here we have infinite iterations of brackets? You gave the right answer with your head. Do you want to elaborate? You don't have to.
For any number n, you can go down to the power set here for which you had that many brackets.
Yes. That's right. So what happens here is that for any n, you can find an element which has like n-level nestings of brackets. But crucially, there is nothing in here where you have infinite nestings of brackets, because everything in here comes from some finite level of this hierarchy. And every finite level has only finite nestings. So it's not that you go from finite nestings to infinite nestings. What happens is that you put together all kinds of finite nestings.